Hi. In the previous video, we were dealing with national income model, finding equilibrium in national income model, but we focused our attention on closed economy. Now we're going to extend this model just slightly to account for the possibility of open economy. So what is changing now? Look, first equation stays the same, right? Equilibrium condition. But now our aggregated expenditures are extended by net exports. What are the next exports? Well, this is the difference between exports. So, exports are all the goods that are produced in our economy at home, but they are sold abroad. So, produced here, but sold outside. And imports. Imports are, of course, all the goods that have been produced outside our economy in some foreign countries, but we are consumed at home. This is why, look here, when we are producing at home and selling abroad, aggregated expenditures on goods produced in our economy are rising. However, if we, instead of buying in our economy, we buy things abroad, those are the expenditures that go outside, and we need to subtract them from aggregated expenditures. Okay, and just as we were assuming that investment and government spending are autonomous, we will have also autonomous exports. We are not explaining them in this model. We are assuming that they depend on demand for our goods in other countries, right? So, it depends, for example, on other countries' GDP, but not on ours. However, it's different with imports. And imports function, you've got over here. This is the new equation, sixth equation added into the model. And look, imports are equal to m times y, which means that they are a function of income. This is actually a function showing us how imports depend on the level of income. So this is a behavioral equation. And we've got a new parameter in this equation. This is m. M is, of course, the derivative of imports with respect to income. So it tells us by how much imports are going to rise if our income increases by 1 unit. This is why we call this MPI, marginal propensity to import. And of course, this is again a ratio, it's not a ratio, a fraction, a number between 0 and 1, and it tells us how much out of one additional dollar we spend on goods produced abroad. Okay, and look, let's just say that now I'm going to solve this model with respect to, okay, let's just write it as it. Income and consumption, and of course something new that we've got, which is imports. Okay, so look, we need to go through the same stages we went previously. We need to condense those three equations, those 6 equations into 3. And we're going to do it, use the same tricks we've been previously. So first I'm going to put these 2 equations together, use the equilibrium condition. So we've got y equals c plus I0 plus g0 plus x0 minus I. Then I'm going to take this equation, substitute for t, and then I'm going to take this equation and substitute for yd, making these three equations into one. So we've got that this is c equals a plus b times yd, which is equal to y minus t. Okay, let me just write it. But then, when I substitute for t, the third equation, I'm going to get b times 1 minus t times times y. Right? So, next, the last equation we haven't used is over here. This is equation for imports. And we've got it. This is a very simple one. IM equals n times y. Okay, and look, also, by the same token as so using the same procedure that we have been relying on all this time, first thing we do, all endogenous variables go on the left, exogenous on the right. So we've got y minus c plus im is equal to I0 plus G0 plus X0. Then we've got a negative B1 minus T Y plus C equals to A, and negative M Y minus plus I M equals to 0. And having this system of three simultaneous equations with three unknowns, we are able to start calculations, and we're going to start as usual by putting everything into matrix notation. So we've got that this is going to be 1 negative b times 1 minus t minus m, negative 1, 1, 0. Then we've got, oh, I made a mistake. Of course, it's here. Here should be plus, right? When we move this to the other hand side, it stays with the plus. So we've got 1, then we've got 0 and 1 again. Okay, so we've got 3 endogenous variables and vector of exogenous terms. Okay, so we're going to start as usual by calculating the determinant. So, the determinant here is going to be 1, then 0, then 0, then plus m, but I'm going to leave this plus m at the end. Also a convention from your macroeconomics class, it's not really necessary. Then we've got 0, and then we've got minus b1 minus t. Okay, look, we've already established that this is between 0 and 1. We know that by assumptions, marginal propensity to import is also between 0 and 1. So, this number is clearly positive. It can be even, technically speaking, mathematically speaking, it can be even bigger than 1. However, using regular conventions from macroeconomics, we will also assume that it is somewhere between 0 and 1. Although remember that technically, mathematically speaking, it could be bigger than 1. We could actually cover a case of very, very small, very open economy, but this is not important. So let's still assume that this is between 0 and 1, which is usually the case. Okay, and this means, of course, that determinant is different than 0, and of course, this means we can find equilibrium solutions. So let's start with equilibrium income. So we substitute the first row with vector of exogenous terms. Okay, so let's calculate it. It's I0 plus G0 plus X0, right? Then we've got 0, then we've got 0, then we've got 0, then we've got 0, and then we've got plus A. And now we found what is the equilibrium level of income. It's A plus I0 plus G0 plus X0, all divided by 1 minus B times 1 minus T. Okay, now that we have income calculated, oh, of course, plus. And again, we see all those are positive divided by a number that is between 0 and 1. So we will get a positive number actually bigger than this. But let's now move to consumption. So calculate AC. So now we replace the second column. 1 minus B, 1 minus T, minus M, I0 plus G0 plus X0, A0, 1, 0. Okay. So, what do we get out of this? We get A, then we get 0, we get 0, we get 0, we get 0, we get plus B times 1 minus T times I0 plus G0 plus X0, and this is how we get our expression for equilibrium consumption, which is given by, of course, A plus B times 1 minus T times I0 plus G0 plus X0 divided by 1 minus B times 1 minus T plus M. Right? Okay. So the only thing left, we need to calculate our equilibrium level of input. So finally we calculate AIM, and it's now we replace the third column, so we've got 1 minus B, 1 minus T, negative M, negative 1, 1, 0, and I0 plus G0 plus X0, A0. In this case, we could actually use use the Laplace expansion because it's really easy in this case, right? I would choose this row, yeah. And what do I get out of it? This is negative M, but I got negative M times the element is in the third row, first column, so it stays negative, and we've got this is negative 1, 1, I0 plus G0 plus X0, and look, if I'm going to take minus out of the first row, first column, what am I getting out of it? Well, I'm getting that this is equal to M times A plus I0 plus G0 plus X0. Consequently, equilibrium level of imports is equal to M times A plus I0 plus G0 plus X0, all divided by 1 minus B times 1 minus T plus M. And because this is nothing more than equilibrium level of income, we can write that this is equal equal to m times y equilibrium. And look, this result makes perfect sense. Why? Well, look, this equation defines imports as MPI times income. So of course, equilibrium imports are MPI, marginal propensity to import, multiplied by equilibrium GDP. Okay, so we know how to solve it, but let's practice it again. This time, let's add one more complication. Let's just say we also wanted to solve this model for t. What should I change over here? Well, definitely, I'm going to need this equation, right, for t. So, I'm going to be substituting disposable income in consumption equation, like here, but I'm not going to go with it any further. So, over here, I will get that this is simply a plus b y minus b t. Here we will have t equals t times y, and I m equals m times y. So, over here, we'll also need to make some changes. So here, we're going to have negative y by plus c plus b t equals to 0. Over here, we're going to have t, negative t times y plus t equals to 0. And we will have finally negative my plus I m equal to 0. And now, based on this, we can build a new matrix form of this model. Okay, so let me start by erasing the blackboard, and then I'm going to move to the solutions. Okay, so we start with the matrix of coefficients, and we've got there 1, negative b, negative t, negative m. Then we've got negative 1, 1, 0, 0. Then we have t, so we have 0, b, and 1, and 0. And then we've got IN, which gives us just 1, 0, 0, 1. Okay, we have these three variables, so y, c, t, in, which are equal to I0 plus G0 plus X0, A0, 0. Okay, yeah, I think I jumped the gun here. Of course, A. Okay, so again, we start by calculating the determinant. We're going to calculate the determinant, of course, this time using the Laplace expansion. Let's figure out what row or what column should we use. Probably, wait, let's choose the second column. Okay, I'm gonna already start with the expansion. I'm not gonna be writing it. Okay, so first we get element negative 1, but this element lasts first row, second column, so it will be times, okay, one last time, negative times negative 1 to the power 1 plus 2, which of course those two will give us 1 anyway. And what if we delete first row, second column, we've got negative b, negative t, negative m, b1, 0, 0, 0, 1. Oh, this will simplify itself very nicely. Then we've got 1 times negative 1 to the power 2 plus 2, which again is going to be equal to 1. And when we erase second row, second column, we are left with 1, negative t, negative m, 0, 1, 0, and 1, 0, 1. Okay, and look, those two are actually extremely easy to calculate because look, if I'm gonna make an expansion by this element, this is just gonna turn into negative b times negative t, negative b, negative t, 1. And look, out of this, I can take out negative 1 from the first column and b from the first row. Okay? And this is simply equal to b b times 1 minus t. Okay, didn't miss anything over here. It's 3, yeah. Okay, and from here, we're gonna get, if I'm gonna make now the expansion by this column, this and this is just gone, and we've got determinant 1, 1 minus m, 1. So this is 1 minus minus plus m. So here we are missing a minus somewhere. This is 1 minus t, b, give me a second, I've taken minus b out, yeah. So, I've taken minus and b, so this is what we got. Okay, so in total, of course we need to add those two up. We get again that the determinant is equal to 1 minus b times 1 minus t plus m, which is again the same result we got previously. We shouldn't be surprised. So equilibrium solutions exist, but we knew that even before calculating this. Okay, so now we just need to find the values of the 4 variables. Okay, so first we calculate ay, which in our case is equal to I0 plus G0 plus X0, A0, 0, negative 1, 1, 0, 0, 0, B, 1, 0, 1, 0, 0, 1. Okay, and the easiest it will be to do expansion with respect to first column. So we've got that this is I0 plus G0 plus X0 times 1B0 0 0 1 0 0 1. And look, you can see that actually this entire expression here is just 1 0 0 0 0 0. So this is actually gone. This is all we've got. Now the second part, now the second element of the expansion is minus a, right? Because this one was with plus, this one must be with minus, and now times negative 1 0 1, 0, 1, 0, 0, 0, 1. And look, again, this whole thing is going to be negative 1 this time, right? So plus A, we've got that this is A plus I0 plus G0 plus X0. So again, we end up with the same solution. So we've got an equilibrium level of income is A plus I0 plus G0 plus X0 divided by 1 minus B times 1 minus T plus M. Okay, so we found that. Now let's go to consumption. So we're going to replace the second column. So we've got AC is going to be 1 minus B minus T minus M, I0 plus G0 plus X0, A0, 0. 0, B, 1, 0, 1, 0, 0, 1. Okay, so expansion, of course, by this column, there's no reason why we should not make it more complex than it needs to be. Okay, so we get that this is first row, so this is going to be minus I0 plus G0 plus X0 times, we will have now negative B, negative T, negative M, B0, 1, 0, 0, 1. Okay, now again, I can get rid out of these minuses and this. And also, okay, and I can make also the expansion, okay, this level. Now, we've got A, that was with minus, that is with plus, and we've got 1 minus T minus M, 0, 1, 1, 0, 0, 1. Okay, so if I'm going to do Laplace expansion here by this element, this is going to reduce to that. And so this is B minus BT. So this is simply equal to B times 1 minus T, I0 plus G0 plus X0. Okay, and over here, expansion by this element will reduce it into 1 plus M. So we've got here plus A times 1 plus M. Okay. And this is of course the result we had previously, so no surprise over here. So we've got that C is A times 1 plus M plus B times 1 minus T, I0 plus G0 plus X0, all divided by 1 minus B times 1 minus T plus M. Okay, we've got two more to go. Right? So, now we're going to deal with taxes. Just give me please a second. Okay, so now we replace the third column with vector of exogenous terms. I0 plus G0 plus X0, A0, 0, and we've got 1, 0, 0, 1. Okay. And this is of course a t. So we calculate this, and again, it's expansion by this column. So we've got 1, 2, 3, 4. So I0 plus G0 plus X0 times negative B, negative T, negative M. 1, O, 1. Again, you see that this is going to simplify very, very nicely. Okay, then we've got minus A times we've got 1, negative 1, 1, and then we've got negative T, negative M, 0, 0, 0, 1. Okay. So, just to make things clearer, let's move this minus over here, and let's see what we can do. Look, here again I would recommend expansion. Let's just say by this row. So what we get in result is negative b times negative t1, 0, which actually gives us simply t. So this entire part from here is equal to t times I0 plus G0 plus X0. And over here, if I'm going to expand by this row, I'm getting minus up front. So we will have a minus A now, and determinant minus t minus m 0, 1. Again, those two cancel each other out, and this turns to t times a. So, if we add those, we are able to finally put the solution for the third variable, and we get the t. So tax revenues in equilibrium are equal to t times a plus I0 plus G0 plus X0 over 1 minus b times 1 minus t plus m, and this is of course equal to t times income with equilibrium level of income. Okay, so the final thing we need to find our level of imports. So we look for I and M. So we replace the last row, last column with vector of exchange terms. So we've got 1 minus b minus t minus m, and this is negative 1, 1, 0, 0, 0, b, 1, 0, I, 0 plus G, 0 plus X, 0, A, 0, 0. And look, this gives us right away that this is the best row to expand, and out of that we get that this is M times negative 1, 1, 0, 0, B, 1, I0 plus G0 plus X0, A0. Okay, so finally, what we need to do over here is to calculate everything out, which gives us 0, 0, I plus X0, 0, 0, and 1, which gives us M times A plus I0 plus G0 plus X0. Exactly. Now we get out of it that I imports in equilibrium are equal to m times I plus a plus I0 plus G0 plus X0 all divided by 1 minus B times 1 minus T plus M. And look, again, we see equilibrium level of income here, which means it's equal to M times equilibrium level of income. Okay, so I hope at this moment you are masters of finding different equilibrium values in open economy version of national income model. So this is it about national income model. What are we going to do next? Look, we already done microeconomic model, market model, and macroeconomic model, national income model. So now let's try something in between. And in the next video, we're gonna introduce sectoral model. So model that is somewhere between micro and macro economics. Okay, thank you for your attention and see you in the next video.